And welcome to CS Explained. In this short tutorial, I'm going to show you how to find a minimum spanning tree on a given graph. So typically, as you can see on the left side here, we have a typical graph you are going to see in such problems. So you're going to have 4 nodes or maybe more, and they'll all be connected. This is called weighted undirected graph. Why? Because it has weights 3, 5, 8, 15, 2, 6, and so on. And it's not directed, means that 1 to 2 is cost is same as 2 to 1. So in this particular case, the cost is 3. So the first thing you want to do when having this graph is typically first you're gonna have to create an adjacency matrix. So I just suggest you copy this on paper and try to follow what I do. So we have 1 to 1. The first means from node 1 to node 1 that you do not have a loop here as said, and then you write 0. Then again 1 to 2 means you need to check the connection from 1 to 2. It has a cost of 3, so you're gonna write 3. Then again we got 1 to 3, we have a connection cost of 8, so you're gonna write 8. And 1 to 4, you're gonna have a connection cost of 15, so you write this 15 here. So we're going into the second row, now checking for the second node. From node 2 to 1, you're gonna have a cost of 3 right here. Again, from 2 to 2, you do not have a loop, so you are going to have a cost of 0, so no path. 2 to 3, we have a cost of 2 right here. And 2 to 4, we have a cost of 5. So this is this. And then we have third row for the third node. From 3 to 1, we got a cost of 8. Then from 3 to 2, we have a cost of 2. And then 3 to 3 again, as you can see, we do not have a loop right here. So you write 0, and 3 to 4, you're going to write 6 because this is the cost. And for the last node, you're going to write 4 to 1, you're going to have a cost of 15. Then 4 to 2, you're going to have a cost of 5, because since you have an undirected graph, this is going to be same as 2 to 4. You can check 2 to 4 is 5, and 4 to 2 is 5 as well. So we've got then 4 to 3 is the next one, which has a cost of 6. And the last one we've got here is going to be 4 to 4. Again, no loop, so we have a cost of 0. So once you've got this matrix complete, typically before you start the problem, you better do this. You're going to have 4 columns and 4 rows because you have 4 nodes in this. And you are most of the time going to get this kind of graph, so don't worry, this can easily be transferred to any kind of a problem. The other thing you have to check for is this. That's what it's in this red order. So you got connection means you write the cost, and you do not have a connection, you write a 0. Now you will not have infinities in this graph. So now we go to this. This is the minimum spanning tree cost. And you can see the node's cost, and T is the minimum spanning tree. At the moment we've got a 0 here, and you've got another table right here. You've got 4 of these rows, means 4 iterations. What is an iteration? Each time you run a loop, you've got 1 iteration. And then we've got E of 1, E of 2, E of 3, and E of 4 for each of these nodes. And actually, what is this about? We've got to add some more rules in here. E connection 1, 2. And this is going to be 1, 2 is going to be 3. They write only the ones that do not have a 0. So, and now we calculate the same for for the node 4. So we just do it like this. Just a minute. Wait a minute. This is going to be like this. C of 4 and node E of 4, right? So what you basically do here is nothing but calculate the route from current node, or cost from current node to the closest node, right? So we've got C of 4, node 4 to E of 4, check in the table. You've got in E of 4 you just have 2. So 4 to 2, you just check this cost, and in your graph is going to be 5. And now once you've got this calculated, all you got to do is take the one with the smaller cost. So simply you are going to add a new one in your graph. So just add a new one in your graph. This is going to be this one because it has smaller cost. So this is the next one. You've just calculated this, so you know it. That's the next one, next connection that you've got, because 3 is less than 5, and you take the smaller one. So you've got this calculated, and you now need to update this table you've got down here right again, once again. According to this rule, so if node is in minimum spanning tree, you just write a 0, and if not, then you assign the index of the closest node in the MST. So in this case, we've got E of 1. 1 is already in the MST, or minimum spanning tree, because it is colored red. So just write a 0 here. Wait a minute until I change color. So 0 here. Then we've got E of 2. Is 2 in our minimum spanning tree? Yes, it is, because it's colored. So write 0 here as well. Then you've got E of 3. Is 3 in our minimum spanning tree? Yes, it is, because it's colored red. So write again 0. And E of 4 is 4 in our minimum spanning tree? No, it isn't. So what we do, assign the index of the closest. Which is closer, cost of 5 or cost of 6? So cost of 5. And then remember, you do not take 5. You take the index of the closer one. So if closer is the one with the cost of 5, then you take index of this node. This is going to be 2. So you just have to take and write 2 here, right? So once you've got this again, you are going to have to calculate the cost for the smaller one, and we did this here already. Now since you are not going to calculate for any other, but the ones that are not yet in the minimum spanning tree, you can do, we can just copy this one here. Wait a minute. So this is going to be what you're gonna have for this one, and since it is the last, it has cost of 5. There's no way you can add it faster than this or with lower cost. You just have to add this one in your tree as well. So let's just add this one here like this, and add here. All you've got to do, we're just gonna copy this as our solution. We're just gonna copy this graph, let's say down here. Now remove all the nodes that you do not need, so like this. These are the ones that are not selected. So okay, so you can see quite clearly here what is your current the last solution. And if you now need to know the problem of finding the minimum spanning tree, you need to calculate the cost, and all you gotta do is add up all the costs. That's all you gotta do. So it's so simple. So we are gonna write, we've got 3 plus 5 plus 2, and all together this is gonna be it's gonna be 10. Just wait a minute till I add these things together. So okay, maybe it's not the nicest, but you get the point, and that's important. That's important. So the final answer is going to be 10. So it's so simple. You've got 3 plus 5 is 8 plus 2 is 10. This is your final solution. How you know you finished with your problem? Well, that's pretty simple. All you got to do at the same time you reached all the nodes. So all of your nodes are in the minimum spanning tree. Or if you're using this one, then you can see that you're gonna have all the zeros here, and once you've got all the zeros up in here, you know that each of these is in the minimum spanning tree, and you've completed your problem. So you're gonna be able to do such problems without having any trouble with it. I hope this video helped you. If it did, please leave a like, subscribe, we're gonna soon have a lot more content, so stay tuned. That's about it. If you're passionate for computer science, just keep watching our videos and you're gonna learn a lot. That's promise. See you.